Okay, today we're going to review domain and range. I know we did a few problems in class, and these are actually different problems. All the problems that I'm going to give you right now are problems that you know how to graph using what you know about parent graphs. So if solving for the domain and range algebraically is difficult, graph it, and then from there try to figure out the domain and range, because these two things go hand in hand. So let's look at our first function. Let's see, what do I have here for our first function? So the square root of 2 minus x. Oh, let me go back to my screen. Here we go. The square root of 2 minus x. You know, y equals or f of x equals. Okay, so we know that inside the square root, I can't have a negative number. 0 is the smallest number I can have. So what I'm going to do is I'm going to set this equal to 0 to see what exactly is the smallest number I can have. So if 2 minus x equals 0, and I add x to both sides, then 2 equals x. So it looks like 2 is an important number. So if I plug in 2, I get 0, and that's okay. And we can actually include 2 with hard brackets. What happens when I put in, evaluate this at 3? What happens when I have 2 minus 3? Obviously, that's the square root of negative 1, and I can't have negative numbers in the square root. That's bad. So 2 is the biggest number I can have. Think about it. I can put 2 minus 1. Whoops. 2 minus 1, that's just the square root of 1, that's not a problem. Even if I went smaller, like 2 minus negative 4. Well, 2 minus negative 4, that's just the square root of 6, because 2 minus a negative 4 is positive 6. And all that works. So solving for 0 let me know that 2 is the absolute largest number I can have. So my domain is going to be hard brackets, whoops. Actually, my domain is going to be soft brackets, negative infinity to 2, because 2 is the absolute largest number I can have, and the largest number always goes last, right? Smallest number to largest number. So that's just one. And you know what? Now let's look at the graph. Oh, let me finish range. So range. We know that anything in a square root can never be negative. Range are going to be the y values, or the output values, or the values that spit out. So if we take a look, if 2 is my absolute largest x value that I can put in here, 2 minus 2 is 0, square root of 0 is 0. Notice no matter what I put in, I'm going to get the square root of negative 6, I'm going to get the square root of 0, I could get the square root of 16, I could get the square root of 100, I could get a square root of 1,000. All those are positive numbers. 0 is the smallest number I'm going to get. So my range is going to be from 0 hard brackets to positive infinity. I can get any positive number as an answer. And now let's actually look at the graph. So let me see, I'm going to turn. I recommend you guys download this app Desmos on your smartphones or use it on your laptops. So let's see, come on, load. Okay, so I think I have this saved. Whoop. Domain and range, here we go. So here's the first function that we just looked at. My square root of 2 minus x. Now, again, you know how to graph this, right? 2 minus x, because the x is negative, it's a reflection upon the y-axis. And take a look here. As you can see right here, let's see if I can mark this up. Right at the x-axis, the smallest value you can see is 2. That's the absolute smallest value. None of the x values on this side are being used, on the positive infinity side. So you can see just by looking at the graph that the domain is from negative infinity and it stops right at 2, and we include 2. And you can see the range. The range are going to be all the y values. Well, look at the negative y values from 0 down to like negative 15 here on my screen. No part of the graph is down there. The entire graph starts at 0 and just increases. That's why my range is 0 to positive infinity. Okay, let's do a few more. So, okay, let's go back. Okay, and let's open a new page here. Okay, so let's see. I'm going to do another one. Oh, square root of x plus 2. Where'd that go? So the square root, so f of x equals the square root of x plus 2. Okay, again, you know how to graph this if you are a little doubtful. But let's try to solve this algebraically. Again, the domain. The domain inside this it cannot be negative. So I have to think of what x values will make this negative. Well, set it equal to 0, and that'll tell you what the largest or smallest value can be. And if we can kind of do this in our heads, right? If I set x plus 2 equal to 0, x equals negative 2. At x equals negative 2, inside here, inside the square root is 0. All right, what happens when I go up one, down one rather? What happens when x is negative 3? When x is negative 3 and I plug it in here, I get the square root of negative 1. Can't happen. Negative 3 is not in my domain. Negative 4 is not in my domain. It looks like negative 2 is actually the largest number I can have. And I'm going to include it. So it's negative 2 all the way to positive infinity. That's my domain. And again, my range here is going to be all positive values. So all positive values, what's the smallest value I'm going to get? 0. All the way to positive infinity. And again, you should get into the routine by now that square roots are going to only spit out positive values where the smallest value is 0. And also square roots cannot be negative inside. So this kind of should be on autopilot for us. And if you're unsure, you should know how to graph the square root function. And let's take a look at that one. So the square root function is this one. Right? It's just the square root parent graph shifted 2 units to the left. So that's why my domain starts at negative 2 and goes all the way. And take a look at my y values. Once again, I don't have any negative y values. 0 to positive infinity. All right. Let's take a look at my next function. And let's see here. Okay, square root of negative x. I'm going to move up. You know what? Let's change it up. Let's use a different color this time. Let's go with green. Okay. So the square root, negative square root of x. I think that's what we had, right? Negative. Yep. Okay. Negative square root of x. Or maybe I should say f of x equals negative square root of x. Okay, domain. Well, what can I plug in inside the square root? Because that's where the x is. The x is inside. What can I plug in inside? Well, I can plug in any positive value, including 0. So from 0 to positive infinity, that's going to be my domain. My range. What are all the y values? Well, take a look here. There's a negative outside. So no matter what I plug in for x, my final answer will be negative. I'll give you a few examples. Let's say I had 16. Well, the square root of 16 is 4, and then I have this negative, which is like multiplying by negative 1. So my answer is going to be negative 4. What if I had the square root of 100? Well, negative square root of 100 is negative 10. Yes, you're probably thinking you can't have a negative value inside the square root, and I don't. But once I find the square root, I have to multiply that by negative 1, giving me negative answers. All my y values, all my answers are going to be negative, with the exception of 0. So my domain is going to be, again, you start with the smallest value. Here it's negative infinity all the way to 0. 0 here is going to be the largest value I get. And again, this is a reflection of the parent graph, so let's take a look at what that looks like. And here it is. take a look. My domain, I'm still using all positive x values from 0 to positive infinity, but my parent graph is now reflected. So I'm not using any positive y values. All my y values are in the negative. That's my range is from negative infinity to 0. Okay. 5 over x plus 3, that's going to be the next function we look at. And if you're comfortable with any of these problems, just fast forward or pause, solve it, and see if you and I get the same answer. So f of x equals 5 over x plus 3. Okay, so my domain, what are all the x values? Here now we're dealing with something different. Here we are dealing with a fraction, and we know in the denominator you can't have 0. Remember I said this in class before? It's okay to have a 0 on the top, but it's a no-no to have a 0 on the bottom. So I can't have 0 on the bottom. Okay, so what's going to make this 0? Negative 3. When x is negative 3, my denominator is 0. I can't have negative 3. I can have any other number though. I just can't have 0 in the denominator, therefore this can't be negative 3. So how do we write a domain when it's all numbers, but I'm skipping over negative 3? This is where we use the union. Negative infinity to negative 3, union, negative 3 to infinity. Okay. And what about my range? Well, my range is going to be any number except what? Well, let's think, can I have 1? Sure. Can I have 2, 3, 4? Can I have negative values? Sure. Can I get 0? Well, the only way a fraction is going to be 0 is if the 0 is on top. That's the only way you're going to get 0. And here I have a constant. I have a 5. That 5 isn't moving. So I'm not going to get 0 as a y value. It's impossible. So my range is going to be every value except 0. So again, I'm going to skip negative infinity to 0, union 0 to positive infinity. Whoops. When you have a rational expression, aka a fraction, and my numerator is a constant, you're never going to get 0. Okay, I hope you've seen this enough that it's kind of second nature to you. We're going to go right to the graphs. So here's the function we just looked at. Let's see here if I can zoom in. And as you can see, notice for the x value, it avoids negative 3. So here's negative 3. Let's see if I can zoom in a little more so you can see. So that's negative 1, negative 2, negative 3. If you count the boxes, each box is 1 unit. It's avoiding negative 3. It's going to hug every other number, but it's going to avoid negative 3. And as far as the y value, going back to the domain, it's every other value, every other x value is being used. And as far as the range, look up and down with your eyes, right? Because that's the y-axis. Every value on the y-axis, axis is being used except 0. See how it skips over 0? Okay. Let's go on to our next function. Let's see, what was our next function? X squared minus 3. Oh, this should be easy. We all know how to sketch this one. This is one of the first parent graphs we learned. Okay, whoop. Okay. Change to blue. X squared minus 3. So y equals x squared minus 3. The domain. What are all possible x values I can plug in without making that undefined? Nothing is going to make that undefined. You can square any number. You can square 0, you can square a positive, you can square a negative number. My domain is negative to positive infinity. And my range. Well, my range, remember, if you square something, it's always going to be positive. So the smallest this number is ever going to be is 0. That's the smallest this number is ever going to be. So 0 minus 3 equals negative 3. Negative 3 is the smallest y value I'm going to get. Because otherwise, no matter the bigger x gets, whether it's positive or negative, I'm squaring it and making it bigger. So my domain is going to be negative 3, including negative 3, to positive infinity. And this, I'm going to sketch the I'm going to sketch this graph right here. You should all know how to do it. So it's vertically shifted down 3 units, and it's a parabola. So notice, this is the lowest point on the graph. So my range is going to be all my y values, so you're looking at your y-axis, from -3 to positive infinity. And you can see for the domain it uses all x values, because as this goes up, it's also getting wider and wider and wider on both sides. Okay. Let's do one more. Okay. Let's see, what graph are we on? Aha. And this one you can solve algebraically. Really try sketching it. What was that again? -2 plus 1. Okay, -2. So f of x, whoops, f of x equals 1 over x minus 2 plus 1. Well, we know that this is a rational function. So I'm not even going to go to Desmos this time because I want you guys to be able to sketch these, because the sketches will help you determine the domain and range. And I know that I'm shifting it 2 units to the right. So 2 units to the right. So I'm going to go ahead and draw. Let me do it in like a highlighted color. Boom, 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 boom. And I know I'm going to shift this 1 unit up. So here's 1. And I'm going to shift this 1 unit up. Okay, and now let's take a look at our graph. Let's actually do this in pink. Here we go. Okay. All right, so let's take a look at our domain. Our domain is going to be horizontal. So you're looking this way at the x-axis. Well, it looks like it's going to negative infinity from here. Looks like it's going to positive infinity here. It looks like it goes all the way until it hits 2. It skips over 2, and then it keeps going. So my domain is going to be negative infinity to 2 union 2 to positive infinity. And let's take a look at my range. Well, my range, I'm going to look at my y value. So it looks like it's going from down here, it looks like it's going to negative infinity, so negative infinity is included. It looks like it goes right through 0, right here. Does everyone see that? And it looks like it goes to positive infinity. It looks like it skips over. It's discontinuous, right? There's a gap here. Well, on the y-axis, what's it skipping? It's skipping positive 1. Take a look. It hugs that positive 1, but it never touches it. So my range is going to be negative infinity to 1 union with 1 to positive infinity. These two lines, these margins, they're called asymptotes, and we're going to discuss this later in the course. Okay, I hope this helps with domain and range. Again, feel free to ask me questions about these or other problems in class. Bye-bye.